Okay, in the second part of section 5E, we're going to solve work problems. These problems involve people doing a job together or alone. So the general formula here for doing a problem of this type is 1 over the time for one person doing the job alone plus 1 over the time for another person doing the job alone equals 1 over their time together. Notice there's an inverse relation here. It's not their times adding, but rather 1 over their times adding. All right, so we're going to define a variable and use it to write and solve an equation, and then use that solution to answer each question. So Zoe and Nick have summer jobs washing elephants in a circus. Zoe, who has a way with elephants, can wash the elephants in 4 hours. Nick, who would rather be sailing, takes a leisurely 6 hours to complete the job. We're wanting to know how long would it take them if they worked together. So 1 over Zoe's time, which would be 4, equals, or rather plus, 1 over Nick's time, which would be 6 hours, equals 1 over their time together, which we're going to call T. So T is equal to the time to wash the elephants working together. All right, what we have is a rational equation, and we can simplify this by multiplying through by the least common denominator. So I'm going to multiply each term by the least common denominator of 12t. So 1/4 times 12t, or 12t over 1, plus 1/6 times the least common denominator of 12t over 1 equals 1 over t times that least common denominator of 12t over 1. Now let's do a little bit of simplification for each of the multiplications. 1/4 times 12t is 3t, 1/6 times 12t is 2t, and 1 over t times 12t is just 12. So we get 5 times t is equal to 12. That's going to give us t is equal to 12 divided by 5, or that would be in a instance where we probably want a mixed number form of the answer. 5 goes into 12 2 times with 2 leftovers, so that's 2 2/5, and that would be measured in the same as the other times, which would be hours. Now, it's important to note that we can have 2 2/5 hours, or we could have an answer of 2 and since 1/5 of an hour is 1/5 of 60 minutes, which is 12, then 2/5 of an hour would be 24 minutes. So we could say 2 hours and 24 minutes as well. All right, in B, we have a pipe filling a swimming pool in 20 hours, and an outlet pipe can empty it. Now we actually have something different that's going on here. We have one pipe that is actually doing a job and another pipe that is undoing a job. So we're actually going to count the one that's undoing the job as doing like a negative job. And we are looking for how long it would take the pool to fill with both pipes open at the same time. So T is equal to the time with both pipes open. So we can use the same idea, 1 over the time to fill the pool for the pipe A, plus 1 over the time for the second pipe. But this time I'm going to count it as negative, so I'm going to count that as negative 1/32 because it's emptying the pool, equals 1 over the time together to fill the pool. So here we're going to multiply by the least common denominator, which is 160t. So multiplying each term times 160t over 1. And now we simplify each of the multiplications. 1/20th times 160t is 8t. And 1/32nd times 160t is negative 5t. And then 1 over t times 160t is 160. So that gives us 3 times t is equal to 160, which gives us t is equal to 160 thirds. Again, for a word problem, an improper fraction is not so great. So that's going to be measured in the same time units. So that would be in hours. 3 goes into 160 in, let's see, that would go in, let's do some long division here. 3 into 160, 3 into 16 goes 5 times. With 1 left over, 3 into 10 goes 3 times. With 1 left over, so that's going to be 53 1/3 hours, or that would be 53 hours and 20 minutes. I'm saying it, but I can't write it. 53 hours and 20 minutes. So one of those two answers, depending upon which form makes more sense. All right, here's one for you to try about typing a research paper. And so try this one on your own and pause the video while you do this. Did you catch this one is slightly different? So this time we have the time together and we're looking for one of their times alone. So this can be set up a little bit differently. 1 over Alan's time plus 1 over Steve's time, which we don't know. So that's going to be 1 over t equals 1 over the time together, which is 4. So 1 over 6 plus 1 over t is equal to 1/4. And we should get 12 hours when we solve that equation. All right, one other type of problem here. We're going to solve distance, rate, and time problems. So remember that when we are traveling upstream, we're going against the current. So the rate in still water minus the rate of the current. And we're going downstream, we're going with the current. So that's the rate in still water plus the rate of the current. So in example 3, this is a distance, rate, and time problem. We're going to set up a chart to organize our information. So Kim paddled her kayak as fast as she could, making it 10 kilometers upstream and then back downstream in a total of 5 hours. The speed downstream was 3 kilometers per hour faster. What was her speed each way? So we have our kilometers per hour, that's the units of our rate, and if we multiply that by hours, we get kilometers. And we also have Kim going upstream and then back downstream. Her upstream trip was a distance of 10 kilometers, and then back downstream, so that implies she went the same distance. And there's a total of 5 hours. Now they talk about total here, so let's put a total row here. The total is 5 hours, so I'm going to put that beneath the hours column. And the speed downstream was 3 kilometers faster. So if we let the speed upstream be x, the speed downstream would be x plus 3. Okay, they're not actually asking us to separate it into current speed and water speed, just that the speed downstream was 3 kilometers per hour faster. Now you notice something that's different about this distance, rate, and time problem. We have x times blank equals 10. Well, if we want to solve a multiplication problem, we solve it by dividing. So the missing part for this chart is the number of hours upstream is 10 over x, because x times 10 over x is equal to 10. And the missing number of hours downstream is 10 over x plus 3, because x plus 3 times 10 over x plus 3 equals 10. Now you notice that we have the two times that total up to 5. So if the total time is 5, the time upstream plus the time downstream is equal to 5. Now we have to solve this equation by multiplying through by the least common denominator, which would be x times x plus 3. So I'm going to multiply the first term by x times x plus 3 over 1, and the second term, or the second fraction, by x times x plus 3 over 1. And then on the other side of the equal sign, we're also going to multiply that by x times x plus 3. No over 1 necessary since we don't have fractions over there. All right, let's do our simplification on each one of those multiplications. Our x factors cancel in the first multiplication, x plus 3's cancel in the second, and nothing cancels in the third. That will leave us with 10 times x plus 3, which is 10x plus 30, plus 10 times x is equal to, and then let's go ahead and do the multiplication on the right, 2, that's 5x squared plus 15x. Now, since we have a quadratic equation, let's do a little simplification. 20x plus 30 equals 5x squared plus 15x. And let's move all of our terms to one side. So I'm going to subtract off the 20x, that'll give us minus 5x, and subtract off the 30, that's minus 30. Notice that all terms are divisible by 5. This is going to make our factoring much easier. 0 divided by 5 is 0. 5x squared divided by 5 is x squared. 5x divided by 5 is x. And 30 divided by 5 is 6. Now we can factor. That factors into x minus 3 times x plus 2. We continue that over here. Either x minus 3 is equal to 0 or x plus 2 is equal to 0. That gives us solutions of x equals 3 or x equals negative 2. Negative 2 does not make sense because that would be a negative rate. And people generally don't speak about traveling at negative 2 kilometers per hour, so we're going to reject that one. And so x equals 3 is our valid solution. Now notice that the problem asks us for what was her speed up each way, upstream and downstream. So her speed upstream was x. So that would be 3, and we'll put units with that, kilometers per hour. And her speed downstream was x plus 3, and so 3 plus 3 is 6 kilometers per hour upstream, and there's our answer. In B, we have another distance, rate, and time problem. A semi-truck travels 300 miles through the flat land in the same amount of time that it takes to travel 180 miles through the Great Smoky Mountains. The rate of the truck is 20 miles per hour slower in the mountains than in the flatland. Find the truck's driving rate in the flatland and in the mountains. Okay, so another distance, rate, and time problem. We'll set up a chart to organize the information. Our rates are measured in miles per hour, so I'm going to start with that. Miles per hour. And that suggests that we should be multiplying by hours and get a result that's measured in miles. And our semi-truck is traveling through two different types of places, the flatland and the mountains. And in the flatland, it travels a distance of 300 miles. And in the mountain, it travels a distance of 180 miles. The rate of the truck is 20 miles per hour slower in the mountains. So if we call its rate in the flatlands x, then its rate in the mountains would be x minus 20. And this is a similar type of a setup. We have the miles per hour times the hours equals the miles, but what we're missing is what's being multiplied. We solve a multiplication problem by division. So our number of hours is 300 over x for the flatlands and 180 over x minus 20 for the mountains. Now, this time they didn't give a total amount of time. They said that it travels in the same amount of time. So the same amount of time implies that these two times, the time through the flatland, is equal to the time in the mountains. All right, so we're going to multiply each fraction by the least common denominator. And that least common denominator is x times x minus 20 over 1. And now we can cancel common factors. X's cancel on the left, x minus 20's cancel on the right, and that gives us 30 times x minus 20 is equal to 180 times x. You might notice that this is the same thing as cross multiplying. 180 times x equals 30 times x minus 20. So if you want a shortcut when you have just two fractions that are equal to each other, you can solve that by cross multiplying. All right, so let's do our multiplication. 30 times x minus 20 is 30x minus 600 equals 180 times x. And of course, now I notice that I've left a 0 off here. It was 300 miles, right? So I'm going to change all these 30s to 300, and then that will change this 600 to a 6,000 as well. Sorry about that. Now we can subtract 300x from both sides, and that will give us negative 120x. Now notice that we can divide, if we don't know, these seem like big numbers, right? So we can divide here by negative 120, but we can reduce our fraction slowly if we want to. So we have 6,000 divided by 120, which if we divide by 10, numerator and denominator, that's 600 over 12. Let's divide by 2 next. That would be 300 over 6. And now we've got an easier division. That would be 50. So x is 50, and that means in the flatlands that our rate is 50 miles per hour. And in the mountains, since the rate in the mountains was x minus 20, that's going to be 50 minus 20, which is 30 miles per hour. What I noticed when I was doing this problem, and the way I found my mistake, is I realized that my answer was going to turn out negative. I must have overlooked something, so I went back and I looked at my work, and I found that transfer error. Sometimes we have to look at it very, very carefully in order to find these.